Hello, in this screencast I will introduce numeral systems. I hope you know them already. You need to know them. The binary, octal, decimal and hexadecimal. In order to express a number from decimal system to any other, you must divide it by the basis of this new system and write down the reminders of the consecutive divisions. So let's start with division by 2. Let's start with the binary system. So the result is 50 and the remainder is 0. Divide again, 25, remainder 0. Divide again, 12, remainder 1. Divide, remainder 0, remind, divider 0, divide, it is a result is a 1, remainder 1, and again you've got this, and you write down this in a reverse order, 1, 1, 0, 0, 1, 0, 0, and it is a solution. Yeah. This is how to verify if it's correct. So it is 0 power of 2 and 2 to the power of 1, power of 2, 3, 4, 5, and 6. 2 to the power of 6 is equal to 64. Then you must add 32. Then you must add 4 is equal to 96 plus 4 is 100 in decimal. That's correct. And I propose another method to do this. I mean, express this from decimal to binary using powers of 2. I hope, or you must memorize this consecutive powers of 2 up to 10. So it is a 2 to the power of 0, 2 to the power of 2, of 1, of 2, and yes, and 16, 32, 64, 128, 256, 512 and 1024. That's all. That's enough. And then try to do the same. So start with 100 in decimal and try to express it using these powers. By guessing. Of course, it's when you start with it is too much. 100. So we must start with 64. 64. What is left up to 100? 36. But you don't have 36, but you have 32. So 36 minus 32 gives you 4. And 4 is here. So first you express a number as a sum of powers of 2, and then put the appropriate ones in appropriate places. So you've got 0 unities and 0 twos, but you've got a 1 4, 0 eighths, 0 16th, 1 32, and 1 64. That's all. Okay. Of course, it is your choice what to use, what method to use. This one or this one. But I propose this. It is simpler when you memorize the powers of 2, and I hope it is faster. Then power. That is the octal system. Yeah, the starting point is better to start with binary, okay, not with decimal. In order to express decimal, you would have to divide by 8. But you could make many errors doing this. So I propose to do this first. So express it in binary and then express it in octal system. And the algorithm is the following. You divide the stream of ones and zeros into 3-bit chunks. And then each of the chunks you must encode using 027 digits. Okay. Here you've got the 4. Here you've got the 4. And here 1. Okay, 0, 0 is assumed to be here. So it is 1, 4, 4 in octal system. Okay, it's very simple because 8 is the third power of 2. And that is a very simple method. In order to express it in hexadecimal, you do very similar algorithm where in which you divide, starting with the least significant bit, into groups of 4 bits. Okay, and then you encode each of the group using hexadecimal digits, which are 0 to 9 and then A to F. I hope you know it, you remember it from the high schools. And as you can see, this is 4 and this is 6. So this is equal to 64 in the hexadecimal. Okay. And how to verify if it's correct? You must know at least the first 3 powers of the hexadecimal and octal system. So here you've got the 64, here you've got the 8, and here is the unity position. And similarly, you've got the unity position and 16 position. So now let's start with octal system. Octal system is in blue color. You've got the 64 unity, 1 times 64 plus 4 times 8 plus 4 times 1. It is equal to 64 plus 32 plus 4. It is 100. Okay. And similarly for this, you've got the 64 in hexadecimal is equal to 6 times 16 plus 4 times 1. It is a unity position, yeah? It is equal to 96 plus 4. It is 100 in decimal. Okay. So your task at home is to do many exercises and examples and calculations. Starting from any of these systems and targeting to the other one selected by you. Okay, do it with your peer and compare the results. Thank you.